So now let's solve problem number 217 over here. And the problem is basically given an integer array. Okay, 217 contains duplicate. Let's make an array over here. This is the array. Okay, given an integer array nums, return true. This is the array over here. Just add some lines over here. Okay, return true arrays nums, and we have to return true if any value appears at least twice in the array. Let's say we have got A over here, B, C, D, A, E. Okay, it's a nums, right? So we need to add number 1, 2, 3, 1, 4, 5. Since it has two values similar, we gotta return true. Okay. And return false if every element is distinct. Distinct means all the elements are different, but here we have one and one which are similar, right? Which is same. So we gotta return true. So there are total four ways, or there can be multiple ways of solving this, but we're gonna discuss four ways of doing this. Okay. The first way is gonna be we are gonna be using the normal brute force technique. We're gonna be using two for loops. Okay. So let's talk about the first technique, which is using two for loops. Okay, so let's write the code over here and then we'll try to understand it. Okay, so contains duplicate, right? So firstly, for I in range, you're looping through the elements. Okay, range length of nums. Okay, firstly let me write the loops over here, then I will make you understand the code. Okay, for j in range of I plus 1, I plus 1 comma length of nums. So what we will do over here is we're using two loops. Okay, so firstly the index I is gonna be, I'll just clear this a bit. Okay, so firstly it's the I is gonna be over here. If we look at this, for I in range of length of nums 1, 2, 3, 4, 5, 6. 6 is gonna be the length, right? And what's gonna be the index? 0, 1, 2, 3, 4, 5, right? For I is less than length. So but for I in range of 0, that is I in range of 0 starts from 0 and it should be length, and it should be looping through less of length than nums, right? So it should be 5, right? It will be considered as 5. So this is our final index till where we are gonna go. And for that to happen, we are gonna keep moving forward. The I is gonna keep moving forward. Now what's the second loop over here? For j in range of I plus 1. What is I plus 1? I 0. 0 plus 1, j. So j is gonna be over here. And it's gonna again go through till the last element. That is, what is it? Length of nums. So that is again, length of nums is 6. We're gonna stop at one element before that. So that is 5. So we're gonna go till here. Okay. We're gonna write a simple code. What is the question asking? If any value appears at least twice in the array. So for that to happen, we're gonna write if. Firstly, let me make you understand what we're trying to do. Okay. So firstly, we'll select I over here. at 0, and this is gonna be the j. Now j is gonna go through each and every element, okay, to the index positions over here. 1, 2, 3, 4, 5. So in the first iteration, since we're using two loops, the first iteration of the I loop, this is the first iteration of the I loop, and then we're gonna go inside the j loop. So j is gonna be going to 1, gonna be going to 2, gonna be going to the third index position, gonna be going to the fourth index position, gonna be going to the fifth index position. If any one of them returns true, if any one of them is equal to element x0 at index compared to any other element, then it's gonna return true. If you look at this, 1 is equals to 1, right, at the third index position. So this condition is gonna return true. But let's say it was something else. Let's say it was 7, 1, 2, 3, 4, 1, 2, 3, 7, 4, 5. So this loop we didn't got anything, right? So we need to go on to the next loop. Now we will I plus 1, and since I is equals to I is at 1, now j is gonna be starting at 2, right? So I will come here and j will come over here, right? So if I is over here at what position? 1, at 1 index position, right? Now this is the second iteration, okay? This is the second iteration. Now we need to compare it with what elements? 2, 3, 4, and then 5, right? 2, 3, 4, and 5. Now again, if any of this element at one position is equal to second, third, fourth, fifth, we're gonna return true. Now let's do for the third element, or the third or the second index position. So second is gonna be compared to 3, 4, and 5, right? Same goes for third. It's gonna be compared to 4 and 5. Now for the fourth, it's gonna be compared to the fifth. Since we don't have any other elements, we're gonna exit. And if any of this condition, if even if 3, 1 comparison of 0th and the third index provided true, all the steps are not gonna be executed. But if it is still not returning true, we're gonna keep going through the last steps. And if any of this condition, any of this comparison is not giving us true, we're gonna return false. That is, every element is distinct. So this is the first step. Okay. So understood the programming logic. Now let's do it over here for nums of I, right? If nums of I is equals to nums of j, we're gonna do what? We're gonna return true. Okay. And if every other comparisons fails, if every loop fails to return false, then we're gonna come out of each and every loop and we're gonna simply do false. Let's run the code now. Case 1, case 2, case 3. Fine. Perfect. So now let's do some other things. Okay. Now let's do the second method over here. Case 1, case 2, case 3 satisfied. So that's not an issue. Okay. Now let's use this sorting technique. It is very easy, man. It's very easy. We don't have to use anything. We are gonna use the sorting function provided by Python. So we have the nums input over here, right? What we're gonna do? Nums.sort. So when we are using nums.sort, let's say what was our input? 1, 2, 3, 1. Let's say we are sorting it. Sort this. So what's gonna become 1, comma 1, comma 2, comma 3, right? That's fine, right? 1, comma 1, comma 2, comma 3. So that's the first step. So now what we have to do is, since if elements are similar, if elements are same, it have to be adjacent, since one is smaller than the two, right? So even if we have multiple ones, it has to be adjacent. Then we're gonna start from 2, right? So for that to happen, it's very easy. So what we're gonna do is we're gonna write the code first. So the numbers are sorted right now, right? Again, we're gonna use a for loop for I in range of 1, comma length of nums. Again, we are doing the same thing which we did over there. If you look at this, again doing the same thing. We're just using the length over here, right? We're starting from 1 over here. I'll make you understand why I'm starting from 1 over here. Okay. Then if nums of I is equals to nums of I minus 1, what we're gonna return? We're gonna simply return true. Okay. And when everything is done, we're gonna return false. So I'll make you understand the code. For I in range of, I'll just copy this over here. I'll paste it. Okay. So nums.sort has been understood, right? Nums.sort has been understood. For I in range of 1, so we are starting a loop over here. This is 0, 1, 2, 3, index position, right? For I in range of 1, so the loop is going to be starting from here. This is the I over here. Length of nums. What is the length of nums? 1, 2, 3, 4. Length is equals to 4. So we're going to be starting from 1, right? And we're going to be going to the third, since we stopped one number before that. So what is the number just before 4? 1, comma 3. So we're going to be iterating from one index position to third index position. Okay. So I is going to go from here till here. But since we have sorted all the elements over here, 1, 2, 3, 4, 5, like 1 is going to be right over here, right? I is going to be right over here, my bad. Okay. So we're going to compare the previous element. For that to happen, we're going to do nums of I minus 1. Okay. Since what we are doing over here is we are using nums of I minus 1, the main reason over here is when we go at the last element, when the I is over here, pointing over here at the third index position, we don't want to say, we don't want to run at outbound errors, right? Since if we do I plus 1, we don't have anything over here, right? We don't have anything. Since we're using a single loop, we don't have anything over here. So what's the safe way to do that? We compare it with the previous element. When I reaches the final loop or the final element, which is third, we're comparing it with the second element. So that's a very simple technique. I starts as 1 and it goes to the last element, and we're going to compare the previous elements. And if it is true, so we'll compare this. Look at this. We'll compare this. It's equal, right? So it's gonna return true. But what if it was different? 1, comma 2, comma 3, comma 4, comma 4. So I is gonna be over here. We're gonna compare it with the first element. Does it return true? No. So we're gonna shift it. Now this two is gonna be compared. Does it return true? No. False. Does it return true? This loop, this iteration? No. Does this return true? Yes. So we're gonna return true. What if this was 5? Then we would have returned false since all the iterations were not able to do true. So we return false over here. Now let's run the code. Hopefully I'm doing a very clear explanation of the code. What's wrong over here for I? Okay, let's make it I. For I in range, it's I, okay? We gotta use double equals to, right, to check if it is true or not. It should run properly now. That's fine, right? So second technique is done. So now a better technique would be using hash set. Okay, we'll talk about time and space complexity at the end for each of everyone, for each and every code. Okay, so right over here, let's delete the code over here. Now let's start with the third implementation. Okay, what is our third implementation? Firstly, what we're gonna do is we're gonna write some code. That is what we do, right? So we're gonna make a scene. What is set? We are making a set in dictionary basically. No, we are making a set in Python, which is inbuilt. Okay, set. So the main characteristic of set is basically, I think it is not duplicated, right? Every element is unique, is distinct. So we are making an empty set over here that is seen. After that, for num and nums, I'll write the code first, then I'll try to make you understand. For num and nums, for each num in the nums list, if num is present in scene, we're gonna return true. Else, we're gonna add that num, same dot add num. Is something wrong with the code? For num and nums, if num and scene, okay, we're gonna do what? We're gonna return true. I'll make you understand the code by copying and pasting that over here. Then we're gonna do scene dot add now and return false. Okay, so let's copy this. Let's add it over here. Simple. Okay, so what we're doing is we're making a set scene. We're making a set over here scene which is empty right now. Empty set for num and nums. So let's say nums is 1, comma 2, comma 3, comma 4, comma 5, comma 1. This is whole nums. What is going to be a single num? This is going to be a single num. This is going to be a single num. This is going to be a single num, single num, single num, and again a single num. Nums is going to be the whole list. For each num and the nums list, if num is already present in the scene, look at this. For each num and nums, if num is already present in the scene, now scene is right now empty. Okay, earlier in the first iteration it is empty, but if it is already present then we're gonna return true. If it is not present then we're gonna add that element, and then or else if It is not written true over here. We're gonna return false for the entire code after exiting the for loop. I'll make you understand that by the example. For num and nums, okay, for each num and num. If num is already now this is seen, now this is nums. If num and seen is empty right now, right? So this condition becomes false. Num is not in scene. So what we're gonna do? We're gonna add something to it. That is, we're gonna add scene to add. We're gonna add that number to the scene. So that's gonna become 1. Now again, for the second number, for num and nums, that is the second. Is 2 present over here? No, it's gonna be added. Is 3 present over here? No. Is 4 present in the nums? Is 4 present in the scene? No. Is 5 present in the scene? No. Now what is this? 1. You see it over here? It's 1 present over here. Yes, it is. So what do we have to do? We have to return true. 1 is already present, so we don't have to add it over here. We're gonna return true and we're gonna exit the statement and the program is done. So that is what is happening over here. There's some indentation errors, I think. The same code is properly indented. Case 1 satisfied, case 2 satisfied, case 3 satisfied. Okay. So there were some indentation errors. After the definition, we had to add a tab. Then we had to keep the same indentation. Then after follow, we had to add a tab. Then after if, we had to add a tab. Then we had to just do backspace and keep the indentation too. So now let's go on to the fourth method. Okay. So it is a very easy logic and which we are it's just single line of code. Okay. I'll write the code and I'll explain that to you. We have the input. We gonna return length of set nums less than length of nums. Okay. Let's copy the code and let's paste it over here. It's a very powerful line of code, right? Firstly, we'll not go inside this. We will assume that this is A and this is B. Okay. This whole thing is A and this whole thing is B. If A is less than B, then we're gonna return true. Or else we're gonna return false. Okay. So nums, I'll try to explain it to you. If nums, okay. What is nums over here? 1, comma, 2, comma, 1. Okay, let's say what is nums again? 1, comma, 2, comma, 1. Right? If we pass on to this 1, comma, 2, comma, 1. If we add a length function to it, now what does it become? 1, 2, 3, right? So it becomes 3 over here. 1, 2, 3. This is the list, right? Now nums is added. Now what we have to add, the first thing we have to do is set. So what does set do? It only keeps the distinct element. So what is it gonna become again? It's gonna become a set that is 1, 2. This element is gonna be discarded right, since it is equal. So it's gonna be 1 comma 2, and we'll add the length. So what is length over here? 1 comma 2. 1 and 2. The length is 2, right? So 2 less than 3. Now return, right? Since A is 2, B is 3, A is less than B, right? So we're gonna return true. There are some elements which are duplicated. That is over here. Since we have the element that are duplicated, the set function is gonna, like the set whatever it is, the set is gonna remove that extra element. So automatically the length is gonna be reduced, right? So it is gonna become 2. And since this 2 is less than 3, we're gonna return true that we do have some elements which are true, that we do have some elements which are duplicated. Look at this. Case 1, case 2, case 3. All are satisfied. Let's submit this. So now let's talk about time and space complexity. For that to happen, we need to again go to the whiteboard, and we should start with the first one, right? And which we were using brute force. So we go over here, let's zoom it a bit. Okay, so over here, we were using two for loops, right? Okay, just a second, I'll just open the LeetCode website over here, and then I will show that to you. Move tab to, I'll just move it over here. Okay, so this is over here, right? So since, because there are, for time complexity I'm talking about over here, because there are two loops, okay, two for loops nested inside each other. They're nesting inside each other for every element. For every element here you have over here, the n element, you check all the remaining elements, right? For I, you check for j plus 1, j plus 2, j plus 3, right? J is basically I plus 1. So for that, you're going through every loops, right? You're going through it over here. For each element, you check all the elements. For each element, you check another elements. For other elements, you check other elements. So you're basically doing n square time complexity. So it becomes n square. The time complexity becomes O n square. And for the space complexity is over here. To look at the code, just a second. The space complexity is basically O1. Why is it O1? No extra space is used besides a few variables, right? No extra space is used, right? No new list or new sorts are created. So we are going to use brute force, and which is time complexity is going to be O1 square due to the for loops, and space complexity is O1 since we are not using much extra spaces. So for now, the second one is sorting. Now, if you look at the time and space complexity, O1 and On, the sorting, this, the thing is over here, the dot sort is going to take On log n, okay? On log n using Python sufficient sort, right? We're using the sort over here. After that, we're taking one pass and we keep the bigger as the, like we're doing on log n, and then we are doing again, we are passing through a loop. So that is on, right? We're using a for loop. So, but we're gonna keep the bigger one. That is on log n. Here it is on, but here that is on log n. So obviously it's gonna be O n log n, which is we're gonna consider the bigger one. And for the space complexity, we are gonna basically do what? It's gonna be O1 or O(n) depending on the sorting algorithm. The sorting algorithm, whatever it uses, the space complexity is gonna be decided on that. So now let's go to the hash set. The time and space complexity is same for this and this as well. We go to the list. We look at this. So we go to the list for ones, checking if an element is in a set. Okay, we're checking if an element is in a set, and adding is about 0 1, right? That is taking the same amount of space. So total time is linear in the number of elements, and space complexity, the set stores each unique element. The set stores each unique element. Okay, so since it is depending on the input, so the space is proportional to n, so it's gonna be O(n). Now if we look at hash set length by using this method, it is gonna be the same, since we're using the same thing, right? We are creating a set from the list which goes through all the elements and then inserts them to the set, which is O(n) on average, but depending on the input. And for the space complexity, it stores all the unique elements. So even though in the worst case, the space is always going to be proportional to n. Okay.